Okay, so the next lesson is on something called permutations. Okay? Perhaps a word that you've never heard before. So I'm just going to start off by just giving the definition of what a permutation is. I think the idea with this concept would be best illustrated through examples. All right, but anyways, permutations, they are the number of arrangements, all right, where the order matters. Okay. So let's just get into the first example here. So we want to know how many ways can a group of 6 friends stand in line? Okay, so this question here, we should actually be able to answer it already using what we learned from the previous lesson, which is the fundamental counting principle. Okay, so all right, so let's say I have 6 friends, and I just want to know how many ways can they stand in a line. So we have 6 spots, right? And according to the fundamental counting principle, we're just going to multiply the number of options for each spot. So for example, in the first spot, there are 6 options, right? Because there's 6 friends. And then the next slot here, or the next spot in line, there's going to be 1 less. So there's going to be 5 options because 1 person is sitting at the front or standing at the front. And it will decrease by 1 each time. Okay, so there's only 4 options here because 2 people are at the front and then the second one, and so on. Okay, so if you apply the fundamental counting principle, we would multiply these together. And what would we get? We would get 6 times 5 times 4 times 3 times 2 times 1. Okay, so 720. So 720 different ways that we can arrange 6 friends in a line. Now, this is a permutation. Okay, so if we were asked, another way to ask this question with the terminology that we have here would be how many permutations are possible from a group using all 6 friends. Right? So the key thing here, again, the order matters. Okay, so so the order that you put the people, right? This is the number of ways where the order matters, right? So we have 6 of the same people, but depending on which way we arrange them, those will be different arrangements. So this is a permutation. Okay. Now you might be asking, oh, what are they called when the order doesn't matter? Those are called combinations, which is what we're going to be looking into a couple lessons down. All right. But okay, so here we have 720 different ways that we could arrange the 6 friends. All right. Now, a little bit of new stuff. So first thing I'm going to introduce, which is new, is something called factorial notation. Okay, so on your calculator, you may have noticed, or you may never have noticed, that there is a button with like an X with an exclamation mark. Okay, so this is your factorial button. And what a factorial is basically what you're doing is actually, you know what, this number 720 is equal to 6 factorial. Okay, so what a factorial is basically what you do is you take that number, you start from there, and you go down by 1, and then you multiply them all the way through until you hit 1. Okay, so 6 factorial is equal to 720 because 6 times 5 times 4 times 3 times 2 times 1 is 720. All right, so the reason why we're introducing this is because we're going to be we'll be looking at a formula for the permutations. All right. All right, cool. So maybe as it like just to kind of hammer this one in. So let's say I want 4 factorial. Right, 4 factorial is going to be 4 times 3 times 2 times 1. So that would be 12 times 2, which is 24. Okay. So let me just pull up the calculator here. All right. Clear that. All right. So 4 times 3 times 2 times 1, we can do that in here, so 24. So 4 factorial is 24. So this calculator has the factorial button here, so if I punch in 4 factorial, I do get 24. All right, now this is going to be handy when we look at the formula for these permutations. All right. Now that being said, what I'm going to do is show the formula with this next example after we kind of work this out using the fundamental counting principle. All right. So again, we have 6 friends, but this time instead of putting all 6 into the line, we just want to put 3. Okay, so if I want to use the fundamental counting principle to answer this question, I would have 3 spots. And for the first option, I have 6. Second option, I have 5. And the third option, I'm going to have 4. All right, so if I multiply these together, this would be 30 times 4, which is 120. All right, so there are 120 different arrangements. All right. I'm just trying to see if I want to visually show you this. Yeah, okay, so yeah, so let's say we have 6 friends. I'm going to try to attempt to draw something here. So say I have 6 friends, so A, B, C, D, E, F. I'm just going to use letters to represent the 6 friends. So we got, I don't know, Alberto, Bruno, Calvin, Doug, Eli, and Frank. There you go. Those are our 6 friends. And we want to just take 3 of them and arrange them in groups. So, for example, one possibility would be A, B, C, right? These 3 guys. We can have A, B, D, A, B, E, A, B, F, and so on. All right, I'm not going to list them all. However, another arrangement that is a different permutation would be like BAC. Right, so even though we have the same 3 people, if we put them in these, if we switch the order of these 2, it actually counts as a different permutation. Okay, so this is called a permutation because the order matters. Okay, and likewise, you know, if I had like CAB, again, this would be a different permutation, even though we have the same 3 people. All right, and what it's saying is there's 120 different ways. If we were to kind of fill this whole thing out, there would be 100. I'm not going to fill out 120 different arrangements, but there are 120 possible arrangements. Okay, because again, using the fundamental counting principle, we have 6 possibilities for the first spot. Then we have 1 less person available, so the 5 for there, and then 4 for there. All right, so there'll be 120. Yeah, so I thought I'd just write this part out just to kind of explain that these are different permutations, okay, even though it's the same 3 people. And actually what I alluded to earlier, a couple lessons down, we're going to be looking at something called combinations. And these are actually combinations where the order doesn't matter. So these would actually be the same combination, these 3. It's just a group of 3 people. And that's kind of like the trickiest part of this actual unit is I find that students find it difficult to differentiate between permutations and combinations. All right, but we'll delve into combinations more in a couple lessons down the road. All right. So anyways, these are main thing here is just realize that these are 3 different permutations. All right, cool. So there's actually, so we can answer this question again using the fundamental counting principle. But now what I'm going to do is I'm going to actually introduce you to the permutation notation. All right, so N pick R. Okay, this is red. Okay, N pick R, where N is the number of possibilities. Or sorry, not numbers. Number possible. I shouldn't use the word possible. Sorry, guys. This is N is the choices, number of choices. whereas R is how many you're actually going to pick. Okay, so if I was to translate this question into this notation, 6, this would be 6, pick 3. Okay, because there's 6 friends, but we're only picking 3. Okay, so 6, pick 3. Now the formula for n pick R is equal to n factorial divided by n minus R factorial. Okay, so this looks like it might be a little bit complicated, but I'm going to just show you how we would have got 120 if we were to use the formula, or instead of the fundamental counting principle. So 6 pick 3 is going to equal to, if I sub this into this right-hand side of the formula, 6 factorial divided by 6 minus 3 factorial. Okay, so again, n is 6 and R is 3. And if we work this out, we're going to have 6 factorial divided by 3 factorial. Okay, so the reason this works is that if I start to write out the 6 factorial expanded out with the formula, 6 factorial again was 6 times 5 times 4 times 3 times 2 times 1. And then on the bottom, I've got 3 factorial, right? So I'm going to have 3 times 2 times 1. Right, so the reason this is the actual formula is because what you'll notice here is that I got 3 times 2 times 1 up in the numerator, but I also have the same thing on the denominator. So I'm going to multiply these together, but then divide. You can see that these actually just cancel out. And what you're left with is so what you're left with is this is going to equal 6 times 5 times 4, which is what we actually used in the fundamental counting principle, which is 120. Okay, so yeah, so I had to introduce the formula in terms of permutations. But in a way, it's basically what it's saying is that, yeah, if I had 6 friends and I want to choose 3, it would be 6 times 5 times 4. All right, now all that being said as well, there is a npickr button on your calculator. Okay, so to be in all honesty, you're probably not even going to use the formula much. We're going to be just using that button. All right, so unfortunately, I couldn't find a kind of an app that I could work with to show you on the screen. So what I did was I took a picture of a scientific calculator. Let me just find it here. Yeah. So for this calculator here, and all scientific calculators should have this option, or this button is right here. So this, if I was to use this calculator to do the last question there, I would punch in 6, and then I hit Shift, and then I would punch, I guess, this button here. So I'd select 6 again, and then I would punch in 3 and hit equals. It should give me 120. All right. So with the calculator that you have, the scientific calculator that you have, you should have this button. All right. So make sure that you know where it is and how to use it. All right. So generally what you do is you punch in the n first, and then you select that operation, and then you pick the R, and then hit equals, and it should give you the number. All right. Cool. All right. So so that's permutation. So we got one more here. Example. Okay. So let's say for the word equation, we want to know how many permutations are there for all the letters. Okay. So if we were to use all the letters, how many permutations would there be? Okay, so so in this case, we can see that this question's asking us, first thing we want to do is figure out how many letters there are in the word equation. So there's 3, 4, 5, 6, 7, 8. There's 8 words, and we are going to pick, or we're going to use all 8 of them. Okay, so so n pick R in this case would be 8 pick 8. Okay, so if you were to just punch this into the calculator. It'll just spit out the number for you. But what I'm going to do here is actually just use the formula. So in the formula, I'll write it back up here. N pick r is n factorial over n minus r factorial. All right, so it's going to be 8 factorial over 8 minus 8 factorial. All right, so if we work this out, we've got 8 factorial over 0 factorial. Now this actually brings up one more thing to note, is that 0 factorial is not equal to 0, right? You might be thinking, oh, well, you start at 0, then how am I going to actually end up at 1, right? It's not even possible. So as a rule, 0 factorial is actually equal to 1. Okay, so on the bottom here would be a 1. So I got 8 factorial over 1, which is just 8 factorial. All right, and that equals a pretty big number, I imagine. So let me just pull up the calculator. 8 factorial, so 40,320. Okay. So that would be the number of permutations, right? And again, so if you were to find your permutation button on your calculator, so if you punched in like 8, and then you punch in that button, so n pick r, and then hit 8 again, and hit the equal sign, you should get 40,320. Okay, so you're going to be using this button quite a bit. Yeah. All right, so next up, let's see how many 4-letter permutations. All right, so this would be 8 pick 4, which is equal to 8 factorial over 8 minus 4 factorial. So 8 factorial over 4 factorial. Okay, so let's just do that. So 8 factorial divided by 4 factorial. I got 1,680. Okay, so this would be the answer. But again, if you just use the this button here, the n pick r, and punch in 8 pick 4, you should get 1,680. All right. If you were to answer this question using the fundamental counting principle, right, you would put up the 4 slots, and you can see that there's 8 options there, 7 options there, 6 options there, and 5 options there. Now, if we multiply these together, we are actually going to get, or we should get, the same number. And let me just show you that. Okay, so 8 times 7 times 6 times 5, 1,680. Okay. Cool. And so just another variation here. So if I had 6-letter permutations, this would be 8 pick 6. Again, theoretically, you can just do this in one function with your calculator. It's totally fine. But what I'm going to do here is just write out the formula. That would be 8 factorial over 8 minus 6 factorial, which is 8 factorial over 2 factorial. All right, so yeah, because what I found is with this calculator that comes with this, I guess, Windows, there's no pick option on here. So I'm going to have to do it this way. So 8 factorial divided by 2 factorial, just 20,160. Okay, so yeah, so you would be using, if you got the scientific calculator, if you just want to use that button, that's totally fine to answer these questions. All right, but just kind of like the key takeaways from this lesson is just to show why this formula is actually the formula. All right, so again, if basically the reason it's a formula is because we want this stuff underneath to cancel out with stuff up top. Right, so yeah, it's kind of, not gonna lie, it's kind of tricky teaching this stuff just in a one-way conversation. I guess me just talking about it without it, because I know there's probably some questions that are arising or that are popping in your head that wish I could explain to you guys live. Anyways, if you're not feeling this stuff, if this is kind of confusing stuff, what I'll do is I'll definitely spend some time during the next live class to perhaps go over some more examples and so on. All right. Cool. So you guys, the assignment, let me just pull that one up. Permutations. Yeah, so so number is 1. Yeah, so all these should be doable. For number 8, it says, maybe I'll just verbally just go through it with you guys right now. Which of the following expressions are not defined? Okay, so we can do some pick 5. Like if you try to punch using your calculator, you will get a number for each one of these, except until you get to D. All right, so the first D doesn't work because N or R, either one of these cannot be negative, right? Because it doesn't make sense to choose from a negative number of items, right? So this one will not be defined, D. As well, E here would not be defined because you can't pick like 3.5 people from a line, right? It's got to be an integer. So D and E would not be defined. F is fine, okay? So even though you spot the 0 here, 7 pick 0, you can actually determine the number of ways to pick no people from 7, which is 1. All right, so 7 pick 0 is 1. All right. Cool. Let me just scan through these ones. Yeah, so these ones, all these questions here, actually should be fairly quick if you use that permutation button, all right, on your calculator. Just a number of ways to just being able to differentiate the number of options, so what your N is, and then how many you're actually picking. All right. Cool. All right, guys. So that's that. If you have any questions, please ask the request help channel, and I'll get back to you. Sounds good. All right. Take care.